located?
Unfortunately, I am from energy conversion area, and my specialist in biofuels is different from your area, but I think there is no problem to join in decision.
I ever visited Java Island, maybe 5 or 6 years ago. I only know Java Island.
Yeah, right. Actually, Professor, his university in east of Aceh. So the Aceh is a Sumatra Islands. So like
the your island, is that right?
Yeah, East Island. East right. I mean the University of Sumatra. If we see there is in the east of the Aceh. Is the Aceh. Aceh is a part of Sumatra Island. It's a small part.
Right. On the north part of your island, right? Aceh.
Right.
Yeah, right.
I know, right.
Yeah, we are in the same area, but it's too different. Not so far from Unsia.
Okay.
Different island from Java.
Have you been to Taiwan before?
No, I never been there. But to Korea and Japan, I have ever been there.
Japan. Okay.
So,
Professor, so we are the most safe area in the world right now.
That's right.
We encourage, Professor.
Yes.
We encourage them. I mean, we give some information to them also, especially for the lectures, and then some of the students who have the outstanding achievements. Maybe some of them can pursue their study also in Taiwan, and then also some lectures can conduct also the research collaboration with the National Central University also. So that's what in this meeting we try to collaborate, and I try to get some opportunity to make joint research and educational program collaboration also, professors.
Okay, thank you. Right. Okay.
Mr. Nas.
Yeah.
We still waiting for the students, or we can start.
Maybe we have to wait because it's only has 12 people here. Professor, because in here is here in early morning because we start on 9 here, so it's today is we start early, so maybe we have to wait if you don't mind.
They wake up not so early, right?
in here is one hours early from Taiwan.
Right now it's 9 o'clock, so in your time 8 o'clock, right?
Yeah.
Usually when your class begin, 8 o'clock or 7 o'clock?
No, the class is at 8 o'clock.
8 o'clock, right?
Right.
Okay. In Taiwan, the early class start from 9 o'clock. I think Chairman won't know, right? If your class start from 8 o'clock, no student will attend the class.
So that's why the student is still hard to join in the early mornings.
Right.
Maybe we just waiting a few minutes, professors, before the student will join.
Maybe we wait until 5 minutes from now. After that, we can open the session.
Right. Okay.
Professor, I still communicate with Wachama also, and then discuss something with Wachama.
How is he right now?
He is busy also. He's busy
in kitchen, right?
Yes.
Okay. Right. But last year, suppose we need to go to Thailand. We had a conference in Thailand last year, but due to COVID-19, okay, they canceled the meeting.
Okay. Yes.
So the next meeting, I don't know when and where. Maybe in Taiwan. You remember ICCMT?
Yes. The last one is in Vietnam, right?
Right, you went to Finland, right?
Yeah, right.
And then suppose last year it should be held in Thailand, right? But actually they canceled the meeting, right?
Right.
Okay, so is it possible for you to travel to other country to join the conference right now based on your grant? Is it possible?
The government is still have the restrictions about to go there to overseas. I mean, so many protocol that we have to prepare before we go to overseas. So we have to check our health, and then some of the country also do not allow the others to enter this country. Also, that's very difficult to go right now.
Okay, okay.
I heard also some of one of the lecture from University Brawijaya is already joined in this lab also, professors.
From Brawijaya?
Yes, in your lab.
You mean ready?
No, I think the other persons.
The other professor?
Yes.
From Brawijaya?
Yes, in your lab.
In my lab?
Yes.
What do you mean? I cannot understand.
I mean, I just heard from the other student in our lab, in your lab. I mean, there are some there is a lecture from University of Brawijaya. They continue. They pursue his study in your lab.
No. I said he graduated from not from Brawijaya. I think it should be ITS or something.
Oh, ITS. Okay.
ITS, all right.
Right.
And he just got the master degree because he's under the double degree program.
I see.
And he received his master degree last semester.
Right.
I think he's not a lecturer. He just graduated from that university, but not from Brawijaya.
Okay,
from ITS, right?
Okay, thanks, professors.
So once your undergraduate students graduate, how many percentage of them continue their study to pursue the master degree in average from your department? For example, if okay, right.
I think most of them just want to work. I think less than 10%, professor.
Less than 10%, right?
Yes, less than.
Only 10%, okay.
Right.
And do they get the job in your island or they go to other islands?
In our island is limit to get some engineering. In engineering work is because we have limits industrial works, so they have to go to the other islands to get. The job is suitable, and then the job is similar with their background. So this is another challenge for us also, how to prepare the students. But we encourage also, we encourage them to pursue their study. I think the most work that I have to prefer for them is to encourage and to support them in terms of the language. So the language is a problem also for us. Even they already study English from the secondary schools, but I think for it still have a lot of improvement in terms of speaking and writing also. It's not similar with Thailand, with Taiwan, I mean.
Right. Even for most the local students in Taiwan, I mean, their foreign language is not so good also, right?
Professor, now is already 37 participants already joined here.
Okay.
Yeah, well, I think we can waiting a little bit. As I already mentioned to you, and Mr. Nasruddin also already mentioned, most of them is just start, is 8 something. They
Okay.
will wake up and then try to join in this meeting.
So, what kind of class is this one? What is the name of the class? What kind of this you say the visual classroom? Okay, what kind of class is this one? Do they accept any credit if they attend this class? How many credit?
Yes, I mean just how to communicate with them.
I think that there's some internet problem there, right?
But yes, I mean for the virtual class, the credit is similar with the normal class.
So how many credit?
Some of the class is two credit, and some of the class is 3. It depends, like in the curriculum already decided. Just how we communicate, because the pandemic we cannot meet them directly face to face, so we just change the media to communicate with them.
Okay.
Just change the media.
All right. So it will be very difficult for you to organize this kind of material, this kind of class. Okay, it takes a lot of time, right?
Yes, the other one is the internet connection also the problem. Some of the students who stay in the others, the other village, they have the bad connection, so they cannot communicate with us also. And then the other one is take a cost also, because they have to pay for the internet. So some of the students may be getting they just thinking how to prepare some budgets to get the internet connection also. That is the other thing that the student sure has to think. But the government already try to teach them, to help them by provide some free connection. They give some internet quota also for them.
Okay.
Sorry, maybe we can start the decision or sessions. Guest lecturer.
Okay. It's okay.
Mr. Irwansyah, we can start.
Okay, Professor.
I'm
Professor
sorry.
And Mr.
Can you check my internal? Can I share my screen
Yes,
to you?
yes, I can see, Professor.
You can
Professor.
see. How about Professor?
Yeah, I can see your PowerPoint.
You can see the PowerPoint.
Yes.
Yeah.
Professor Lai.
Yes.
Yeah, I just introduce you, and then the moderator will be held by Mr. Nasruddin. But
Okay.
I will follow you. I still here. I do not go anywhere. I still do this one. And then the Mr. Nasruddin will be organize and lead this this virtual conference like webinar.
Sure.
So I will give to Mr. Nasruddin. Mr. Nasruddin, is your time to opening.
All right.
Okay, thank you, Mr. Irwansyah. Good morning, everyone. Thank you for joining with our conference here, and thank you for attending this conference. And for today, the guest lecturer will be by Professor Jiing-Yih Lai from Mechanical Engineering Department, National Central University, Taiwan. Maybe for the curriculum vitae, we don't have now, Mr. Irwansyah. Maybe you can explain, or you can write the brief introduction or brief about the Professor Jiing-Yih Lai. Maybe you can tell for everybody here, Mr. Jiing-Yih Lai area, research area, and everything that you can tell to us here. Please, Mr. Irwansyah, to brief introduction for us.
Okay, thank you, Mr. Nasruddin. Then, Professor Lai,
Yes.
it's our pleasure to invite you in this virtual class. I mean, many of lectures and then students also may take beneficials in this class. So thanks for the all of the participants. Right now is already 58 participants from the student and the lecturer also join in this meeting. We hope it will be increased in few minutes. Let us because this event is, I mean, rarely we can meet some of the lecture from the others university, especially from the professor the others university, because the pandemic I think make us can see everyone even from even is not face to face or directly meet. At least we can see uh, how they can introduce their work, their research, how their education also share with us. This one is most important. So today's as Mr. Nasruddin, as the vice of the Dean, Faculty of Engineering, University of Samudra, Bangsa, East Aceh, already explained a few. Today, our guest professor is Professor Jiing-Yih Lai. He is a professor from Mechanical Engineering Department, National Central University, Taiwan. He is our, and for me he is my professor. He teach me a lot. It's not about the research. He teach me about how to manage and organize some works also. He teach me about how to study. Many things I got from him. So he is like, if I can say, he's my mentors also, because as I know, he is not just research professor. He already also took some of the important responsibility in the National Central University. The last one that I know, he is the one of the head of mechanical engineering department. When I went there, he is still the head of mechanical engineering department in 2000. I think in 2015, he is the head of mechanical engineering department. So the others, I think in the previous, he is many of responsibility from his university. He also already took. So today we are very lucky. In his time, I know he's very busy. To he already conduct also some collaboration with industry. I think for us, thanks Professor Lai already spends your time to give us some of knowledge, some of the lecture class also. We hope everyone in this event we can join after he finish until he finish his speech for today. So he is graduates from Ohio University in US from the master degree and PhD degree. Most of his research, I think, is based on the computational. Some of with the engineering measurements. But for me, when I went there, I asked him, "Can you teach me about how to use computer-aided design, computer-aided engineering to help the medical problems?" So that's why he teach me about many in terms of computational base for the medical applications. So today we ask him to speak how Taiwan can leading in terms of smart manufacturing. I know him can explain this one, because in our lab also we conduct some like a weekly meeting group. So sometimes I heard his opinion, his vision also, how's the Taiwan going from the heavy industrial to the, now we know is like the smart industry. So many artificial intelligence, AI is already changed many things. Also like the data mining, and everyone who want to study about smart manufacturing, at least he has to know this kind of the field, artificial intelligence, data mining, and then everything related based on the computers. It will be, I mean, required. So today, the topic is smart manufacturing, computational simulation to enhance small manufacturing enterprise. Even the Taiwan is small islands, we can see they have the big products, the big effects in terms of the manufacturing process in the manufacturing product. So we can learn and we can hear from the professor how the Taiwan can change this one and can lead in some part of the industrial. So the words have the depends. I mean many things about the Taiwan. So please welcome for the Professor Lai to give the speak, and then for the moderators, this webinar it will be held by Mr. Nasruddin for the lead, and then for me just to introduce what is the Professor Lai research interest, like I already mentioned in before. For the time, please Professor Lai and Mr. Nasruddin to continue this lectures class.
Okay, thank you, Mr. Irwansa. Excellencies, ladies and gentlemen, today we are very happy because among of us is we have one of professor that have much experience about smart manufacturing. Hopefully, with this session conference, we have the huge impacts to our manufacturing area. And today, this session attended by the lecturer from Universitas Jiing-Yih Lai and also from Universitas Samudra. In this session, we will hear about the smart manufacturing computational simulation to enhance small manufacturing enterprise. For the attendee, please theory clearly about the presentation from the Professor Jiing-Yih Lai. And after this session, after the presentation session, we have the question and answer questions. In that session, you will give a question for the professor with two kind of the. Maybe you can raise your hand and type on or put your question at the chat room. And then for Professor Jiing-Yih Lai, time and screen yours.
Okay. Thank you all professors for your introduction, all right? And for ladies and gentlemen, okay, so I start my presentation. The title, okay, of my presentation is Smart Manufacturing, okay, Computational Simulation to Enhance Small Manufacturing Enterprise, okay. Before I describe the title, I will briefly introduce myself a little bit, okay. As Dr. Wang already said that I'm right now in the mechanical department, National Central University, I received my PhD degree in 1989. It was around 30 years ago, 35 years ago, right? Right now, I already joined NCU for more than 30 years. So actually, it's quite a long time. My research area, I changed a lot. From the beginning, my research area was in precision measurement and actually shifted a lot. And for the past 10 years, my research work focused on CAD, reverse engineering, and computational geometry, and the morpho analysis, and so on, right? Because I already worked for more than 30 years, I already published more than 90 journal paper and 117 conference paper. And the importance I want to emphasize that for the past 30 years, I already acquired more than 130 research projects. Okay, about 45% of them was sponsored by MOST, which is the Ministry of Science and Technology, which belongs to our Taiwan's government. All right, another 50% were sponsored by industry. I want to emphasize the project from the industry because when we perform a project from the industry, all right, actually our result should be very useful for the industry. And all our students, when they join this kind of project, they can learn a lot from the industry. So my talk today will be focused on those kind of projects related to 3 companies we did for the previous 5 to 10 years. Okay, the first one, okay, the company called NewMax. Okay, this company, okay, is something related to the optical industry, right? And their product mainly focus on lens or camera lens. Okay, for the lens company, this is a very large industry in Taiwan. So this is the first company I want to mention about. The second issue I want to mention about, we call the MIM, metal injection molding, and the company is called Vincent. Their product, okay, we call the metal injection molding. Their product just the metal product, metal parts, okay, and the common of those 2 companies, they always use injection molding for the manufacturing. The first one, the material use the polymer material, and the second one, they use the metal part, and I will mention that one later on. The third company, which is related to this area, okay, is Cortex. This company is called Cortex. Their product is a software. This software is called the Model 3D, and this software is very famous, okay, in morpho analysis. I know that there are 2 famous software in this area. One is by AutoCAD, called Morpho, okay, and the second famous software is Model 3D, and I will mention that one later on. Okay, so now let's come to my outline. First, I will describe the problem of those projects related to those companies. The first one related to the optical area. Okay, I will mention the motivation and the project we are working on in this area. The second one is another company. This is related to metal injection molding. Okay, so I will talk about the problem related to those 2 projects, and then I will briefly describe the morpho analysis. Okay, because for those projects we always use a morpho analysis for this kind of work, and then I will describe the simulation result on the first one, and then the second one, and finally a brief conclusion. So let's describe the first area, optical lens and camera lens. Okay, and I just emphasize the motivation of our project and the research work in this area. Do you have any problem? I mean, can you no problem there, right?
No problem, Professor. It's clear.
Okay.
The voice
Yes.
and the PPT is also clear. You can see.
Okay. All right. Okay. So let's continue. First, because there are a lot of students there, so I briefly describe, I mean, what is the lens and camera lens industry, okay? So for optical lens, okay, they are commonly used in visual camera. For example, in your cell phone, iPhone, or a lot of cell phone, notebook, we have some camera for notebook, security camera, and so on. Most of those camera, okay, they have some plastic lens, and I have some picture here. Okay, those are typical product, okay, using injection molding, and the diameter of those are very tiny, maybe for example less than 3 millimeter in diameter. Okay, and those plastic lens, they are made by injection molding. All right, so those are typical the result from the injection molding. And in injection molding, we need to design and fabricate a mold. And for example, this mold, the accuracy is very precise. Okay, because the quality of those lens is very much higher. So usually we need computer aided engineering or computer simulation. Okay, try to understand the process of the process, and then we can help to design and manufacture the mold. Okay, and the application of computer aided engineering, okay, typically they are used in structural analysis. I think you are more familiar with this one. Also in thermodynamics and also in fluid analysis. Okay, some of you may be familiar with this one. In injection molding, okay, this kind of CAE we call morpho analysis. I will use MFA later on to represent a CAE analysis in injection molding. Typical defects, okay, on injection molding for the general injection molding, including, okay, those are defects typical appeared, and for the entire process, we want to eliminate, okay, those defects. For example, burr, inner mark, bubble, air trap, okay, welding line, sink, and so on. Particularly, okay, for lens industry, okay, we more concerned on first one we call the optical path difference, because maybe there is some kind of stress concentration on the product, and the optical path maybe become different on different area, and it will result in a better quality of the lens. So we need to study, the optical path difference. The second one we call the horse racing effect. If this is a typical example, if we have a multiple cavity, if the runner, here's the runner, if the runner is not designed properly, okay, it will, the flow will be changed a little bit, okay, and here we call the unbalance in flow, and the result, the flow in different cavity will be different, and this kind of effect we call the horse racing effect, and we want to eliminate this kind of result. And the other one is we call the flow front. In the simulation, okay, this is a real experimental result of the flow initially, okay, and then the final result. And in between, we have different stage of flow front, and we hope that we can check and evaluate the flow front. Okay, those three, we are concentrate on those three in terms of the lens industry. And the importance of morpho analysis, okay, when a mold is designed, okay, usually just based on engineering experience, okay, and unless we already manufacture the mold, we don't have any data to analyze the new design. Okay, so this is the traditional problem, because only focus on engineering experience. For example, for this mold, okay, and if we did not use some kind of computer simulation, once we design the mold, the runner, okay, so this is the runner, the cooling channel. Cooling channel is embedded behind this cavity. Also, the location of the gate. For example, where we need to design the gate, here or other orientation. Okay, so those issues cannot be changed if we already fabricate a mold. So those parts are difficult to change once the mold is manufactured. So if we apply morpher analysis can be used to simulate and the process and to help to design and to manufacture a mold before it is really fabricated. So this is the importance of morpher analysis. Also, by using morpher analysis, okay, we can also try to optimize the process parameters. We can study and optimize the process parameters. So this is the importance of morpher analysis. So here's a typical result, okay, of morpher analysis for lead. Okay, for example, this shows the simulation of optical path difference. Okay, once we know the situation, we know how is the situation of the optical path, and also we can simulate the flow form, and also we can try to analyze and understand the result of the flow unbalance. So here's the motivation of our research. Okay, actually, for the most lane company, they are large enough, so they already have some CAE engineering to perform CAE analysis for their daily work. Okay, when they have a new design, they will perform CAE engineering. But why they still want to cooperate with the university? Okay, I'm sorry. Sorry, okay. So why they want to cooperate with the university? Okay, actually they want to enhance the knowledge of the morpher analysis because there are a lot of technology should be studied. Okay, so they want to initiate this kind of project and cooperate with us. So before I go into the detail, I want to change another issue. Okay. What is metal injection molding? Okay, here I still give you the motivation of our research work in this project. I think metal injection molding is I think new for everyone because plastic injection molding is more common. Metal injection molding is not so popular. Okay, actually, metal injection molding it belongs to one kind of injection molding, but it uses metal powder instead of polymer as the material in the process. For example, this is the metal powder and combined with binder. Usually the binder is wax. Wax and the metal powder combined together and mixing together and become, we call the feedstock. And the feedstock is sent into the injection machine and to come out the injection part. Okay, so metal powder is mixed with the binder first to form the feedstock. And the feedstock is used in the injection process, and we come out the part we call the green part. This is still not the final product because the green part here, the green part is still combined the metal powder and the binder. So finally, we need to use a process called the sintering to remove the wax, to remove the binder, and to come out the final product. And the final product is purely metal. So this is our final product. So this picture shows the green part. Actually, this combined with the metal powder and the wax, but this is not so strong. It is easy to be broken. And after the sintering, we come out the final product. And for a lot of product, they use this kind of process to produce the part because it uses the injection molding. So the production efficiency is quite good. For example, if you want to produce 1,000 or 2,000 of parts, you only take, for example, maybe 1 or 2 days, you come out the final result. But if we use the CNC machining, because for each part, for the CNC machining, okay, it may take maybe 1 or 2 hours. So for the CNC machining, the efficiency is not so high. This is the main reason of using metal injection molding. But the problem is that because the feedstock of metal powder is not so strong as that of polymer material, so there are more defects on this kind of green part compared with the polymer plastic part. Some of them, such as, okay, for example, they are easy to be broken. Okay, there is some kind of sinkage on some of the internal hole, and a lot of crack may happen, okay, on the part. Okay, most of the defect can be removed. Okay, during the process we can adjust in the process parameters, but a major problem is that the cooling problem. What is the cooling problem? Usually, when we design a mold, we usually use we call the two-dimensional cooling channel. So this is the two-dimensional cooling channel. The cooling channel is embedded inside the cavity or inside the core. Okay, because this is just a two-dimensional, so it can be fabricated using CNC machine. But the problem is that we may have some area. Okay, the temperature is very high. We call the highest temperature area. For example, in this example, this area, the temperature is very high, and using two-dimensional cooling channel, because we have a lot of mechanism there. So the cooling channel, they cannot be close to this area. Okay, usually they are, when we design the two-dimensional cooling channel, okay, it is a little bit far away from the high temperature area. So the result is that because the temperature on the central area could be accumulated. Okay, when the injection process is continuously working on, okay, and it will result. I mean, the temperature will be increased slightly, and finally it will be result in the instability of the process. Okay, when the injection process is running for a long time. So this is the main problem. So the motivation of this study is that even so, the MM part are quite small. Usually, okay, for example, their dimension is less than 30 millimeter. So this is a typical part. But the main point is that, okay, it has a lot of holes there, and the traditional two-dimensional cooling channel, okay, they are not good enough, okay, because due to the limitation of the mechanism, they are a little bit far away from the highest temperature area. So how to solve this problem? Maybe we can use we call the conformal cooling channel or three-dimensional cooling channel. I will explain that one later on. But if you use three-dimensional cooling channel, the manufacturing is the problem. So this is the issue we want to deal with. So this is the second project we are working on. Before I discuss those two projects in detail, I want to briefly describe a morpho analysis, okay, because maybe some of them are not familiar with morpho analysis. The morpho analysis software we use, okay, is by Cortex, okay. Actually, we have project with Cortex, okay, for about 10 years, okay. And the content of our project, okay, we try to develop some software, some program for them, okay, develop some algorithm for them, okay. But I will not talk about that issue, okay. In today's talk, we use this software to deal with the previous two issues we discussed, okay. So here, Model 3D is the commercial okay, morpho analysis software. Okay, and here we emphasize, okay, the issue we emphasize how to study this software, and then we try to improve the simulation result. Okay, even so, we use the commercial software. Still, we still need to study something, and then we try to improve the simulation result. I will mention more later on. So let's talk about morpho analysis. Okay, as I mentioned before, injection molding, okay, this is common use, okay, okay, in polymer or in metal powder. All right. So okay, so this is a common manufacturing process. All right, and injection molding can be used for quite a lot of material. Here we focus on metal and the polymer two types. The typical cycle of injection molding divided into 4 stages. The first one we call plastification. Okay, the solid feedstock enter into the machine, and there is heater here. Okay, when the solid feedstock enter into the machine, and it is heated and turned into melted state, here into the melted state. And this is the first stage. And in the second stage, I mean, the melted material is pushed forward into the cavity by the screw, okay? And this is the second stage. We call the filling of the injection. So we have melted material is pushed forward into the cavity. This is the second stage. And in this stage, we call the flow rate control. The machine is controlled by the flow rate. Means that we keep the flow rate in different level to push the metal material into the cavity. So this is the second stage. In the third stage, we call the packing and cooling. So in this stage, all right, the machine turn into we call the pressure control mode. Okay, we use a different level of pressure and push material more into the cavity. So more material is pushed back into the cavity under higher pressure to compensate for the decrease in the volume. When this is during the cooling stage, the volume will be decreased. So we need to push more material into the cavity, okay, to make sure the cavity is perfectly filled until the sprue is solidified. So this is the third stage we call the packing and cooling under pressure control. And then finally, we eject the part and also the other such as runner and the waste and so on. So this is the typical cycle of the injection cycle. And what is the advantage of morpher analysis? Okay, so let's take a look at this picture. In typical process, okay, for example, once you design the mold, and you need to test the mold, and usually we need to repair the mold again and again, maybe try 3 times. So it takes a lot of time and a cost to modify, to repair the mold. And once the mold is ready, and whenever we want to produce the mass production, still we need to check the mold, test the mold, and repair the mold again. Okay, so this is the typical process if we did not use the morpher analysis. So once you use the morpher analysis, because it can be used to simulate the entire process. So if there's any problem, we can know and we can correct the problem before the real mold is designed and manufactured. So this is the typical process when morpher analysis is used. So the advantage of using morpher analysis, okay, first we can shorten the development cycle, the time, and we can reduce the cost for more tests and more repair. And also we can solve some possible problem before mass production. And finally, the total cost can be reduced. Okay, so this is the advantage of morpher analysis. I think typically in many industries in Taiwan, they already use morpher analysis before they really design a mold. So this is quite useful and commonly used in modern industry. Okay, let's talk about the process of morpher analysis. Basically, it's divided into first, in the process, usually we have a CAM model or part. So we need to convert the model into we call the solid mesh. So here we call the first stage we call the solid mesh generation. Okay, we need to convert the part, the CAM model of the part into solid mesh. And also not only the part, we also the runner and also the mold base and also the cooling channel. all those main part we need to convert into the solid mesh because we need to perform the numeric analysis. Okay, so we need to convert the model into the mesh. The second stage we call the parameter setting. We have a lot of parameters need to be determined, such as machine parameter, material parameter, and also process parameter. Those parameters we should determine. Once we determine the parameter, okay, we can input the model combined with all parameters and into the solver, and the solver can perform numerical computation. And finally, you come out the result. And for the solver, it usually takes by hours, maybe 4 or 5 hours or days, because it takes a lot of time. But I mean, the solver can do it by itself. So actually, we don't need to do anything. Okay, once we come out the result, okay, so here's the post-processing. Okay, the engineer analyze the result and evaluate the result. And if the result is not okay or is not satisfied, or if we need to change something, we need to go back and start from the beginning. We can change the mesh, or we can change the parameter, and we can do this one again and again, and finally come out with some satisfied result. So this is the typical process of morpho analysis. So here shows one example of some parameter we need to determine. For example, here are some parameters during the filling stage. For example, we need to determine some temperature for the material and for the mold. And also we need to determine some the volume, I mean the amount of material for each cycle. We need to determine the flow rate, and the injection pressure, and so on. And another stage, packing and cooling, we need to determine different level of pressure and the different time for each level of pressure, and also cooling time, and so on. So typically, those are parameters we need to determine during the entire process. And here shows the interface. We determine, for example, this interface is used to determine the flow rate in the filling stage, and this one shows another user interface to determine the pressure in the filling stage. Okay, how to determine those parameters? So in morpho analysis, okay, the parameters are determined. Okay, first for the machine parameter, usually, okay, when you already have one machine, you already know the spec of the machine. We can just select the database from the software. The software already performed the database for the machine. So there's nothing you can change once you already use a specific machine. Same thing there for the material. If you already select the material, okay, the material parameter already embedded in the software. So you also only select the material from the database. Also, I think you don't have any chance to change the material unless, for some situation, for example, in AM process, maybe this kind of material is not on the database. Then we need to ask the company, okay, to test the material. Okay, we need to generate a new database for the material. But usually, for common use material already saved in the database, so we don't have any chance to change the material. But the third one we call the process parameter. Okay, of course, for the process parameter, because we have a lot of parameter, temperature, pressure, flow rate, and so on, we need to set up. But because for the company, usually they already have a lot of experience, so we only choose the parameter for example, we have previous product we already produced. We only follow the parameter for the previous product. So therefore, it could be a good start to use the process parameter of existing product. So for the process parameter, we don't have any choice to change. The only thing, okay, we can study is we call the solid mesh, okay, because I will tell you that because if you use different solid mesh, the result of MFA analysis will be changed a little bit. So here, okay, so the method to change the mesh, okay, we still need to study for different kind of cases. Okay, so this is only one issue we need to study. In terms of the mesh we use, usually we have 4 kinds of solid mesh typically used. The first one we call, okay, for example, this is a CAD model we convert into solid mesh. So this is the first type of solid mesh we call tetrahedral. Okay, in short, we call that tetra. This is the tetra mesh. Each cell just a 4 face represent a cell. Okay, actually each face just a triangle. So this is the typical one and the most common one. The second one we call the prism. All right. On one side we have triangular type, but on the other 3 types, actually each cell we have 5 faces, 2 triangle and 3 rectangle. So this is the typical shape of a prism cell. And the third one we call the BLM. Okay, this kind of mesh, okay, is the typical, a particular one in model 3D. On the surface, it is a prism type, but the inside it is a tetra type. The final one we call the tetrahedron, or in short we call the hexa type here. All right. So the quality of this type is the best one. And okay, so for the tetra one, it's easy to be generated. Actually, for the software, this kind of mesh it can be generated automatically. Okay, but the main problem is that the accuracy is not so good. Okay, why I mean that when you get the simulation result, for most of cases, the result is not, the accuracy is not so good. And the prism one and for the hexa one, for those 2 kind of mesh, actually we call the structure type, the accuracy is much better. Okay, so for the prism and the hexa, usually we prefer to use prism and the hexa. But for those 2, the problem is that actually they cannot be generated automatically. All right, so we need to put a lot of manual effort to edit and produce those 2 types of mesh. Okay, if we have a CAD model, so it takes a lot of time to produce this kind of mesh. And for this one, because this is a particular one by model 3D. All right, so so it can improve this one. Okay, it include the accuracy a little bit, but still not so accurate compared with this type. But for this one, okay, we can generate this one semi-automatically. So in terms of the manual effort, this one is better than this one. So typically when they use model 3D, usually, okay, initially they use this one. But for some reason, if this accuracy is not good enough, then we need to try to shift to either this one or combination of this one and this one. So basically, this is the situation of 4 kinds of solid mesh. Okay. So let's go to the main issue, our project. Okay. So for the first project we work on, okay, actually we emphasize how to generate appropriate mesh in order to study some issues on land simulation. Okay, so in this project, the objective of this project, okay, we want to study mesh generation, and we want to develop appropriate type of mesh. Okay, and we emphasize the following 2 issues. First, we want to simulate the whole racing effect. So this is a typical whole racing effect here. For this runner, for example, okay, this is a symmetric. We have 2 parts here. Here we call the barrel. We have 2 parts here, and the runner, the pace of the runner, they are symmetrical. So ideally, the flow should be balanced on 2 parts, but actually they are imbalance. For example, in this example, no, here, this is a little bit faster than this area. Okay, so first, the morpho analysis must truly simulate the whole racing effect. If there's whole racing effect, and then if we perform the simulation, any problem? Excuse me.
Yes, no, Professor, you can continue. It's still
Okay, all right. Okay, so let's continue here. Whenever, okay, what is the reason we want to simulate the whole racing effect? Okay, if the whole racing effect appear, the computer simulation should truly simulate this kind of situation. So this is the motivation. And then once, okay, we using this simulation, we can simulate this kind of phenomena, and we can use the simulation, okay, to design a new runner. Actually, we want to eliminate this kind of phenomena, but we want to study the simulation. We want to make sure the simulation can truly reflect the real situation. So this is the background of this study. The second one, we want to simulate the flow form on very kinds of length. So this is a typical flow form on an actual experiment. Okay, so here and this kind of experiment we call short shot. Okay, so what I mean that when we perform the injection molding, for example, if I fill 100% of material, this is the final result. If I only fill 10%, so this is the result of them. Increase to 15% and so on. Okay, so here we call the short shot. Okay, we can obtain this kind of real experimental. So experimental short shot can be performed, and we can come out the result. Okay, and using this result, we can demonstrate and we can use to compare with the simulation result. So the Morpher analysis should display the same trend before this. This simulation can be used further. Okay, so this is the background. We have some experimental result, and if we perform the simulation, we want to show the same trend and to demonstrate that this simulation is good enough. So let's discuss the first issue. Okay, the simulation. Okay, based on how to simulate the whole racing effect. And in this project, okay, we use 3 real cases. So case A, B, C. So these are real case. Here's the runner, and here's the real, we call the barrel, real part. And in this example, for example, we have 8 barrel, 8 parts on this design, and we have 4 parts on this design, and we have 8 parts on this design, and so on. The reason we use 3 examples. Once we come out the result for the 4th example, we want to demonstrate that this kind of result can be used for the 2nd and for the 3rd example. So we, the point here, we want to study the solid mesh for 3 kinds of runner, okay, and using different kind of mesh combination. And then we perform Morpher analysis to evaluate the result. And also we compare with the experimental result. And I think the bottom line is that we want to establish the standard operation procedure to generate the mesh, all right? And once we come out this kind of procedure, and we are sure that the mesh is good enough to perform the simulation, and we can redesign the runner based on the simulation, and we can come out a good design to eliminate the flow unbalance in phenomena. So this is the objective and the motivation. Okay, I already explained. The flow unbalance. Okay, Basically, okay, this is the result. Okay, the reason is that when the flow make a turn, because we have some, we call the shear force. We have some friction, and because of the friction, we can generate the feed. This kind of feed we call the shear heating. So when the flow make a turn, resign on the left side, the temperature is a little bit higher, and on the right side, the temperature a little bit lower. So the flow because the temperature is higher, so the flow here is higher, and the flow on the right hand side is a little bit lower. So it results this kind of result. So even for those 2 parts, on the left side, the flow is faster than here. So this kind of phenomena we call the whole racing effect, and we need to how to redesign the runner so we can eliminate this kind of phenomena. And before that, we need to study how to using simulation to redisplay this kind of phenomena. So this is motivation. Okay, so this is one example. Okay, this demonstration show how to generate the mesh. This is the original CAM model, and this is the mesh we use. Okay, divide into two color, and well, I don't want to go into the detail. Just to give you the concept that we need to use this kind of mesh. So result. Okay, we need to analyze the geometry. Okay, for example, some of geometry they are regular shape. Okay, and some are irregular. Okay, for the regular shape, for example, those the blue one. Okay, we use one kind of mesh, and for irregular shape, the red one, we use another type of mesh. Okay, so basically this is the kind of strategy. Okay, and here shows the composition of the irregular shear. All right, and for the regular shear, and for depend on different type of shear, we need to figure out how to generate the mesh for the regular shear, and even for the regular shear, we have the first one, and also we have the second one, and we need to come up different kind of strategy to generate the shear. Okay, and for the irregular one, okay, we use another type called the BLM, and here is the procedure to generate the mesh. Okay, so this is the detail. I think we don't need to discuss too much, but here's the result. Okay, for this kind of the runner, okay, we come out this kind of combination, and for the blue one, we use the hexagon mesh, and the red one, okay, we use the BLM mesh. So this is what the company want. They want to know what kind of mesh and also what kind of dimension we use for this kind of example. So, and for those three example, we always come out this kind of result. And here I show you, the different, if we use different kind of mesh. For example, if we use first one, if the entire runner, you use BLM mesh only. So this example we obtain. Ideally, okay, we want to see the difference because for the actual experiment, the flow is different here. But this is the simulation result. The flow on those two parts are quite the same. So this one means that this simulation is not good. So this is wrong simulation. Okay, so it means that if we only use this mesh, the result is not acceptable because this is the real result. And so this kind of mesh cannot be used. If we change this one we develop, and as you can see, okay, as you can see, the flow here is a little bit higher than here, and also you can see here the flow here a little bit higher than here. This one means that because in this situation we have the flow unbalance, and the simulation can reflect this kind of result. So this is the good relation, and this is the good mesh we can use. So this is we come out this kind of result. And once we know the simulation can reflect this kind of the flow unbalance, and we try to modify the runner. Typically, this is what they do. For example, this is the original design, and once we change something on some particular region, all right. So this is what they do. Okay, so before this is the original runner. After we redesign the runner, and here is the simulation. As you can see, we check the flow here, and it seems that the flow becomes more balanced. So this one means that once we change the runner, the result seems okay. If you did not use the simulation, what you can do is that you change the design, and you fabricate design. You run the test. If the test is not good enough, you need to come back and to adjust the design, to repair the design. Okay, it takes a lot of time and also cost. And because we use this kind of simulation, we can predict the result before the modification is fabricated. Okay, so this is the good process we can use. So this is the best. This is the first issue we started, and we come out this kind of result. And this is okay. This is okay, and also satisfied. The company is satisfied this kind of result. Okay, so basically this is the first result in the project we deal with. The second issue, okay, we try to implement morpho analysis on length study. Okay, For length, okay, the each for length, they are a lot of different kind of lengths. Okay, some of them are used for iPhone, for cell phone. Some of them are used for we call it VR, visual reality. The lens used for visual reality is quite different from that one used for cell phone, and also for car. Okay, for visual camera, different kind of camera, they have different kind of design of the lens. And here shows the cross-section of a typical lens. As you can see, we have a lot different kind of design, but some of them may belong to the same type. All right. So here, the shape of lens, they change significantly. Okay. And when a new mode or when a new lens is designed, the mobile simulation should be implemented to simulate the engineering process. Okay, the problem is, okay, when we want to perform the simulation, how should the mesh be generated so that the simulation can reflect the real situation? So this is the main issue we want to study. Because, for example, if you already perform this simulation and you know, I mean, you know what kind of mesh you want to use, but when you design and you use a new mesh, you don't know what kind of mesh you need to use. So this is the issue we want to study. So here's the objective. We study mesh generation for different kind of lens, and we want to try to figure out what kind of mesh we can generate for different kind of lens. And here, actually not just 6 types. Right now we study more type. Okay, so company give us 6 type of lens and also the CAD model, and we want to study different kind of mesh generation and we want to come out a better type of generation for each type of lens. So this is the motivation and objective. Okay, so here, because we want to perform mesh generation, so we need to divide the lens into different regions, and for different regions, we using different kind of lens. Okay, so basically this is the strategy we use. For example, in this example, okay, we divide the cross-section into 3 regions. Okay, and for each type of region, we apply different kind of mesh. And when we want to generate the mesh, okay, for some specific area, we need to divide the mesh and the region and to apply appropriate mesh. So basically, this is a lot of detail there. We need to take a lot of time to study the shape and try to evaluate what kind of mesh we want to generate. So here is one example. Okay, for example, this is the entire model. Okay, this is the entire mesh. Right, and for some specific area, we apply different kind of mesh. For this example, for this area, we use the BLM mesh. For the other area, actually, we use the Hexagon mesh. Okay, so those are 4 typical type of mesh for use for different kind of lengths. Basically, we combine the green one Hexagon mesh, the blue one BLM mesh. But the difference that the area might be changed. Also, the mesh type may be changed. So we have a lot of parameter combination we need to study. Okay, so this is the first example. Okay, for this type of lens, for example, we perform different kind of mesh generation. Okay, for example, for this type, we use Hexagon mesh, and this is the parameter for the mesh size, and so on. So for this row, we mainly use Hexagon one, but with different kind of mesh size. But the second one, we mainly use BLM with different kind of mesh size. And finally, we compare the result, and it seems that this result is more close to the actual experiment. So this is the result we obtain, and we need to do the same thing. Okay, for this the second one. Okay, for the second one, as you can see, this one, quite similar to this one, but so we can perform similar study, and this is another result we obtained, and those results are quite similar to the real result. And this is the third type. As you can see, the third type is quite different from this one. Okay, so even so they belong to the same length, because they belong to different type. All right, so they perform different kind of flow front. And so we need to do the same simulation again. And we come out this kind of combination, and the result is quite similar to the real experiment. So we did all those type of 6 type of, the simulation, and we come out the best combination for the first one, second one, third, and so on. So those are the good result. We think that we can fit to the experimental result. Okay, and also of course we need to record the combination of the mesh and also the some parameter related to the mesh. Okay, so once we know what kind of mesh is suitable for different kind of the mesh. Okay, how to use this kind of mesh generation method? Okay, because we have so many type of mesh, all right, and how to use our mesh generation method. So we developed and we call the main classification program. Actually, we are working with the company, and we develop this program. And by using this program, if the user input one new lab, okay, and we can automatically determine which type this lab belong to. For example, here we show that all those pictures belong to the same type. We call the type A, and divide into 2 subtypes called A-1 and A-2. Okay, and for example, for the lab belonging to the same type, we can use the same mesh generation approach. So here is the approach. So a mesh generation method for each type of lens is suggested. For example, for the type A, we suggest this kind of mesh generation. Okay, and this is the result we obtained. Okay, I think one of the important things is that we develop a program to classify different type of lens. The second one, okay, is we come up different kind of mesh generation for different type of lens. So we come up with this result. And this project is still undergoing right now, and we already achieved some result because we already work with this company for the 4th year. This is the 4th year, okay, and we will continue this project. We already come out some very good, some very interesting result. Okay, so this is the second issue. Okay, I'm talking about. So for the first one and the second issue, even so we use the commercial morpher analysis software. So still we can focus on how to study mesh generation in order to improve the simulation result. So this is really what the company want. Okay, so this new project, the third issue is the new project. Okay, we called we want to design a new mode for the metal injection process. All right. So this project was sponsored by most and the one company called Vincent. Okay, I talked about before. And this project already performed for 4 years. This is the 4th year. And during the past 4 years, we already design and fabricate 3 modes. And also we test those 3 modes. And also the reason is that we need to design new cooling system. Okay, so here's the background here. This is the typical MM part, metal injection part. Okay, because it has a lot of holes, and for those holes, okay, because we have some ejector, because the mechanism is very complex. Okay, so and also for this particular part, for the mold design, not only the injector pin, we also need to design some slider mechanism because we have some hole along the vertical direction, some hole are horizontal direction. So in terms of injection molding, we need to design the mold so we can eject some part horizontally and some part, some pin horizontally and some pin vertically. So this mechanism is quite complex. And for this kind of structure, the cooling channel, it cannot cross to the central area here. This is around this area, the temperature is very high, but the cooling channel only around this area, not close to the high temperature area. So two-dimensional cooling channel can only be located far away from the central hole. Okay, so the temperature will become very high. Okay, so how do we accomplish this kind of problem? Solve this kind of problem. So we need to come up with new mode design, and what we use we call the 3D cooling channel. Okay, but why is 3D? I will mention 3D cooling channel because for traditional 2D cooling channel, for example, because those cooling channels are embedded on the material, we can using drilling to drill the hole along this direction, and so on. So if you use the 2D cooling channel, traditional drilling can accomplish this kind of manufacturing. But for three-dimensional cooling channel, we have some curvature embedded on the material. So drilling cannot be used for this kind of manufacturing. So the only thing we can use, we call the 3D printing. Okay, usually 3D printing is just for polymer material. This is just for prototyping. But here we call the metal additive manufacturing. Actually, it is also belong to 3D printing, but using metal powder instead of polymer powder. Okay, so here we call the metal additive manufacturing. But the quality of the metal additive manufacturing, actually, the surface quality is not so good. So we need to combine CNC machining and 3D printing together to come out the final mold. So this is the best objective of this study. So here I talk about the traditional process, okay, of design and manufacturing of mold. Okay, so this is the traditional process in MM process. Okay, for mold design, okay, based on the experience, we design the 2D cooling channel. And actually, in the traditionally, they don't use the mold for analysis. Okay, and then use CNC machining for the mold manufacturing. And then once we come out the injection part, okay, they then send into the sintering to remove, I mean, the binder to come out the final. So those are two final parts. Actually, those two final parts are for lugs. So for that kind of material, I mean, that kind of part, okay, actually they use this kind of process to fabricate those kind of I mean, the parts. Okay, so this is the input method we use for the mold design, because we need to design 3D or conformal cooling channel. Okay, so because we need to design the 3D cooling channel, so we need to implement more for analysis to study, I mean, the effect of 3D cooling channel. And then for the more manufacturing, we need to combine, I mean, the 3D printing and the CNC machining. We need to combine more method together. And I will talk about metal adaptive manufacturing more later on. Okay, so actually we already fabricate 3 molds. Okay, so this is the third one, the final one we are doing right now. We already come out the result. Okay, so I talk about this one a little bit in detail. For the company, okay, for the original mold design and manufacturing, actually they already fabricate 2 traditional molds. So this was the first one we call the 4O design. In this old design, as you can see, this is the part. There are not many holes there. Maybe they fabricate this mold maybe 3 or 4 years ago, because at that time they think that because the actual part we had a lot more holes, but at that time they think that maybe they are not able to fabricate the part, so they only remove some hole. They only leave 1 hole here. Once they come out the result, they just perform the secondary machining using the CNC machining to drill the hole. So this was the first design in their mold. Okay, using the traditional 2-dimensional cooling channel, and as you can see, even for this part, already have a lot of mechanism there. So the mechanism is quite complex. That's the reason they don't have a lot of space there. They can put their cooling channel. Okay. So around one year ago, okay, they design a new mold. They fabricate a new mold. So this is their new design, because once they use the original design for 2 or 3 years, they think that the first thing that they need to change the mold, and they already know that okay, they can the new mall, they can put more hole there. So in the new design, okay, they already put more hole. If they already, so the hole already fabricated, they don't need to perform the secondary machining. So this is the new design, okay, of the new mall. Also two-dimensional cooling channel. But in this design, as you can see, more injection pin are located here. Okay, so this is the new design, and actually this is the new two-dimensional mode they are using right now in their production. So in our development, okay, we use the three-dimensional cooling channel. So this is the typical three-dimensional cooling channel. What I mean that the cooling channel embedded inside the mode, we can adjust the shape of mode arbitrarily, as long as we have space to embed the shape. And we need to design the shape, and we need to design the location. Okay, so we have a lot of choice to design. So this is one of the results we come out. And here shows some of the picture in different kind of shading mode and so on. So here shows the concept of our new design. But the point is that we need to have different kind of design, and we need to run simulation, and we finally we want to come out the best result we can obtain. So here are some cases we did within maybe 2 or 3 months. So this is the original one, two-dimensional. Initially, we just want to try to modify the shape based on the original design. So here we just modify the shape slightly, okay? And we have run 4 cases, for example. And then because we run the morpho analysis at the same time, and the results are not so good. Okay, so we try to modify the shapes much more. Okay, so I think this is the second stage. Okay, we only change the shape. Actually, those are 3D cooling channel. Okay, we only change the shape, but still we think we find out the result. The result, what is the result? We want to decrease the highest temperature. Okay, we can, after we perform the morpho analysis, we know the highest temperature area. We want to decrease the highest temperature. Okay, but the result are still not satisfied. So we come out another design. Not only the 3-dimensional cooling channel, we add another cooling channel here. We call the Baffle cooling channel. Okay, we add 2 types of cooling channel together. So this is the final result. Okay, we come out. What I mean that we use morpho analysis to help us to study the design. And whenever the result is not so good, the simulation result is not so good, we come back and to redesign. And in this stage, we don't need to fabricate a real mode. So this is the advantage of morpho analysis. And here I show some of the results we evaluate. For example, this result shows the surface temperature after the feeding stage. Okay, the surface temperature, the distribution of the surface temperature from the minimum temperature to the highest one. And here we show the highest temperature. For example, for the original, the surface temperature is 38.4. And the point here, we want to reduce the highest temperature. And for different design, as you can see, the temperature is decreased slightly, but still not satisfied until we reach this place. Okay, the high temperature is the minimum one. So this is not the final result, because the highest temperature actually not occur on the surface, is on the central. We also observe the central area. Okay, so on the central area, for example, for the original one, the maximum temperature is 75, and here on the final design, we reach to 69. Okay, 75 drop to 69. We drop around 66 degrees. Okay, and of course, whenever we come out the result, we bring the result and we discuss with the company people. Okay, and finally we agree this result, this design might be good enough. So we finally choose this result as our final result. Once we come out the result, we need to design the entire mall. Okay, so this is the final result we designed by our students. Okay, from the beginning to the final result. Okay, I want to briefly describe the cavity and the core, because this one was made using 3D printing. Maybe some of you are not familiar with this kind of technology, so I want to describe this one a little bit. Okay, so this is we call the here we call the female core. This is the male core, and this is the original CAM model. And based on original CAM model, we want to perform the 3D printing using the metal, okay, to perform the 3D printing. And remember that the cooling channel are embedded inside, because we have three-dimensional curve embedded inside. That's the reason we cannot use CNC machine. So what we use, the entire core, either the female or male, we need to fabricate with 2 more using metal adaptive manufacturing. And here shows the design, okay, on the model, okay. Here shows the the cooling channel and need to be redesigned, and here shows the upper section of the mold we design, and the lower section of the mold we design, and here's the I think this is the male. The male part is insert on the mold base. Same thing, the female part is on the outside part. Okay, so this is the relation between the male part and the mold base. Okay, so this part need to be fabricated using the 3D printing. So this is the result of 3D printing. Actually, we use the commercial 3D printing machine, all right, to fabricate this part. I mean, the dimension of this one actually is quite large, around, for example, 20 centimeter, 30 centimeters, that kind of issue, all right? And this is the female cavity, this is the male cavity. The only problem is that the cost is very high. For this part, if we only, just give you one example. If we fabricate, we use CNC machining to fabricate the entire mold, it cost us around 10,000 US dollar, around 10,000 US dollar to fabricate the entire mold using traditional CNC machining. Okay. Okay, those 2 parts, for each part, it costs around 5,000 US dollar. Means that if we add 2 together, it costs about 1,000 US dollar. Okay, once we fabricate the part, we also need to fabricate the mold base, and also we need to perform the secondary machining. As you can see here, the surface quality is not so good, so we need to perform the secondary machining. So in total, when we fabricate the mold using this kind of strategy, the total cost may be 2,000 US dollar. So the only disadvantage of this kind of mold design, that is the cost. But of course, it depends on your requirement. Okay, so here's the result of 3D printing for the female and for the male. Okay, so for both cavity are made using the metal additive manufacturing. All right. Okay. I think I don't have too much time, so I will go first. Okay. So this is the final result for the female mold and the female male. So this is the part original using the metal additive manufacturing, but after CNC machining. So this is the result. This result is quite good. But unfortunately, when we perform the mold testing, for some reason, because this company, this was their first time to fabricate this kind of core. So unfortunately, they made some mistake. Okay, there is some leakage from the cooling channel. So okay, so they try to fix the problem, but unfortunately they cannot fix it. So at that time, we need to reproduce one of the male core again, and the only difference is that for the original one, we already for the 3D printing, we already add a lot of hole, but for the new design, we don't need to fabricate the mold, the hole first. So this is the second part we obtained. And after this one, when we perform the secondary machining, we drift the hole, and then we can overcome the problem. So this is the final mold we use, okay, for the male one and the female one. And once we come out the entire mold set, we perform the testing. Okay, I don't want to go into the detail. And here are some of the results for the short. Because when you perform the mold testing, you need to adjust the parameter one by one. Okay, based on the previous result, we adjust the parameter. And finally, we come out the good result, and then we come out the optimized set of parameter for the process. All right. So here are some of the results. We call the short. All right. And then finally, we come out and once for the entire process, we have some defect. Okay, we need to adjust some of the parameter, try to remove some of the defect, and we come out so this is the final result. I think from 13 to 16. Okay, those results are satisfied. And before that, we have some defect, so we need to adjust the parameter to overcome those shortfalls. But this mode just tell us that, okay, based on this design and the verification, we can come up a very good result. And also, we also test the highest temperature about 2 days ago. Okay, and we find that if we compare if we eject the mold, and we measure the temperature for the traditional 2-dimensional mold and our new 3-dimensional mold, the hyper temperature can be decreased about 5 to 6 degrees, which means that using our new mold, the highest temperature can be decreased a lot. Okay, so actually, I mentioned now we test we fabricate 3 molds. So this was the first one we did. But at that time, around 3 years ago, the motivation here, we want to test whether if we use the metal additive manufacturing, can it be used to fabricate this kind of precision mold? So this was the motivation at that time. And okay, so this is the result. But okay, we just come out the result. But we just come out the result. But we did not evaluate the accuracy of the part at that time. And for the second one, it was made 2 years ago. Okay, this is the new part and the new mold we come out. Okay, and at that time we want to check whether the result is acceptable or not. So for the second one, not only we obtain the green part, we also win this green part for sintering. And so this is the final result we obtain. We remove the wax, and this is the final part, and the final part seems acceptable. So this was the second one we used. And for the final one, we just come out the result. And because the final one, because we have more holes on the part and more complex on the mechanism. So for the third one, we already demonstrate that we still can use this kind of technology to fabricate this kind of part. But we just okay. The only problem, as I mentioned before, the cost. The cost around twice higher than the original 2-dimensional mold. So this is the only disadvantage. Okay. So finally, the conclusion. All right. Okay. So when solid mesh of fate, okay, the morpho analysis, okay, quite a lot. Okay. So in this study, we study how to use different kind of solid mesh to deal with different kind of phenomena we face, okay, for land industry. This is the first issue. But the second issue, okay, for the MIM industry, okay, we combine the metal additive manufacturing and the CNC machining. We try to implement 3D grid channel, and also we implement more and combine those technologies to fabricate a new design or more, and then we come out a very good result. I think the final result is that because most of our graduate students, okay, are involved in this kind of industrial project, okay, actually graduate students, they can be trained quite well through this kind of project. Okay, the problem, the main issue is that because they need to meet with the company people either twice a week, once per 2 weeks, or even once per month. So actually they can learn a lot. After they graduate, okay, actually they find a very good job. Okay, so this is my conclusion of my presentation. Okay, thank you a lot. Thank you so much for your listening. Okay.
Okay. Thank you for the great presentation. I think this presentation is very useful to us. By sharing this presentation, give us the new perception, particularly new knowledge about moldings and simulation. Hopefully, we can continue with the collaborations. Okay. And now we come to the opinion, question, and answer sessions. Please, for the audience to participate by giving the question and answer. But I see in the chat room, it is have many questions, and maybe I will read one question. Okay, Mr. Prof. Jiing-Yih,
yes,
still there? Okay. This has one question from the student, or oh no, from Zainal Arif. And the question is, what is the main problem occur when we start to use simulation?
Can you speak it again? Make question. Okay.
Okay. Next question is, the simulation involve flow and molding fluid dynamic and manufacturing in a simulation. How maybe the question is how to make a simulation in one simulation involve two kind of simulation. This is have a dynamic, fluid dynamic, and manufacturing in one simulation. I think that's the meaning of the question.
You mean just use one simulation, not on instead of two simulation?
In one simulation.
To come out the result?
Yeah.
Okay. Okay. I don't know whether this this answer is correct or not. Okay. Because okay, if you don't use simulation, all right. For example, when you have a lens design, all right, even for lens design or even for MIM mold design, right? If you don't use simulation, okay, usually you need to design the real part and then manufacture the real part, and then once you test the part, test the mold, then you come back to repair the mold. It takes a lot of time and effort and the cost. But when you perform simulation, right, because it's just computer work, okay, you can do it once, twice, and twice. It does not cost too much. It only takes some time. All right. So in terms of simulation, usually we perform a lot of simulation. Okay, we want to optimize, for example, some of the process parameter. Okay, or we want to use better strategy for generate mesh. So we need to perform a lot of times. So when we perform simulation, not just once. I don't know whether this is the answer or not, right? So whenever we perform simulation, actually we do a lot of times. Is that correct? I mean, to answer the questions.
Okay, I think that's correct answer. Maybe the student can understand what you mean of the answer. We have many questions here, but if anyone want to raise hand and want give a direct question to Professor Jiing-Yih, please to raise hand and you can give a direct question to Dr. Jiing-Yih.
Mr. Nasruddin,
okay.
Professor
Lai.
Lai.
Introduce you.
Professor Lai.
Yes.
This is me. Actually, maybe we can explain first. Most of the process that you present today is injection molding technologies.
Yes.
So maybe some of them do not understand yet why we select the injection moldings, because actually injection molding is one of the technology that can provide huge numbers of the product in one time of the process. That's why we consider the injection molding as one of the technology that we want to encourage for the small enterprise also, that can, based on the huge numbers of product that we can fabricate in one time, maybe the cost it will be less if we compare with the others. That is the first one. I mean, for the first question, the student want to know when they want to start the simulation, what they have to prepare first. I mean, the step how to conduct the simulation. I mean, that's the first question that Mr. Nasruddin already read before. The student not yet know well how to conduct the simulations, how they prepare it. I just want to say that.
Okay. I'm sorry, all right. Because for different kind of manufacturing process, all right. Okay, computer-aided engineering, CAE, actually this is the common type of simulation. We call it CAE, computer-aided engineering. All right. CAE is very popular in Taiwan's industries. For example, if you have some kind of structural design, you may perform CAE analysis to make sure that whether your design is good enough, is strong enough. Okay, so another thing, when you, for example, if you have some other design related to, for example, fluid mechanics, okay, you might perform CAE analysis for that kind of simulation, right? Morpho analysis is one kind of CAE analysis. It is one kind of computer simulation. And the morpho analysis, especially for injection molding. All right, so for injection molding, when you want to provide CAE analysis, usually the special term we use, we call the morpho analysis. And for morpho analysis, we need to use special type of software, and two common software in the world. One belongs to AutoCAD company called Morpho. The second one, what we use here in Taiwan and also in mainland China, we call the Model 3D. All right, so this is the background of using the CAE software. And if you want to study, for example, different kind of manufacturing, for example, you want to design a structure, actually you will use other software. The most common one is called ANSYS. ANSYS is a very common software for structural analysis. That can, of course, there are other software already available for different kind of area, different kind of operation, and different kind of study, right? And for morpho analysis, okay, especially for injection molding, right? Only for injection molding. This is the software we use only, right? And the reason, okay, the reason we focus on injection molding, well, because we receive projects, okay, from the company, all right, and because, for example, on this slide, the first company, their product, okay, are optical lens, plastic optical lens. Okay, so their material is just plastic material. Of course, we also have some lens using glass, all right. But as you know that if you the lens using glass, that's for camera, for normal camera. But in terms of mass production, in terms of digital or visual camera, they don't use glass as their material because it costs higher, and also it means the cost is very higher. And if we use the plastic material to fabricate, the lens, the cost is very cheap. All right. So in Taiwan, we have at least 4 to 5 very largest company. Okay, they only, for example, we have 1 or 2 company. The iPhone, the visual camera, okay, around maybe 90 or more than 90% of visual camera in iPhone, they are made by two of the largest company in Taiwan. So the marketing is very high. And for the second one, the metal injection molding. Okay, what I should believe that metal injection molding, okay, their product, the accuracy is not so high compared with CNC machining. The CNC machine, the accuracy is very high, but the part from metal injection molding is not so high. Why? Because after they perform the injection molding, okay, they need to perform sintering to eliminate the binder. Okay, when you perform the sintering, the volume of the part will be decreased around 10 to 15%. Means that whenever you have an original one, the volume is 100%. Okay, then after you perform the sintering, the volume will be decreased to either 90 to 85%. So it is a little bit difficult to control the accuracy of the dimension. So usually for metal injection molding, okay, the advantage is that because they use injection, so the efficiency is very high, but the accuracy is not so as better as the CNC machining. So you need to, but whenever you have a new design, you need to choose which kind of manufacturing you will apply. Okay, so for metal injection molding, most of them they use for very small parts. Okay, but not for very large parts, because if you want to use metal injection molding for large part, mean the accuracy is difficult to control. Okay.
Okay, Prof. I think it's the great answer, and we have many questions here, but I will give the chance for the people who want to give the question directly. Please raise your hand.
Dr. Nasruddin.
Yeah. Please, Tovan, who is want to give the question?
Okay. Yeah.
Please introduce you.
Excuse me, Professor.
Storing, the sound is storing.
Right.
I have two questions, maybe. I want to ask about manufacturing. How is manufacturing process for manufacture boat or yacht, maybe manufacturing process for boat or yacht from composite material, Prof.
Can you understand? I'm not a little bit not clear.
Professor Lai, I got his questions. Mr. Tovan,
Yeah.
he asked about how to manufacture the composite materials.
How to manufacture composite material?
He said.
All right.
Yes,
Yeah.
because
Okay.
as we know, in some parts, like the yacht or some of the ships, is manufactured by using like combine the polymers and some like the natural fiber or synthetic fiber also. Is it possible, and how is to manufacture, and it can be simulated also or not?
Okay. I am not familiar with this field, but all I can say that by using morpho analysis, for example, more 3D, actually they provide this module for composite for the simulation of composite material, because for today's polymer material, they are not using the pure material. A lot of composite material, because they have different kind of orientation. For example, they put fiber into some kind of polymer material. So of course, the morpho analysis can perform this kind of analysis. We know that, but we haven't studied that kind of field. Yes, it can be used for simulation, model 3D, right? No problem.
Okay, thanks, Professor. Mr.
But
Tovan.
I'm not familiar with that field. Yeah.
Mr. Tovan, Professor say Modex 3D can be used also to simulate the composites materials also. You can use this kind of the software to help your research.
Okay. Well, I can explain a little bit more about my background with this company, Cortec. Okay, because Cortec, this is the company to produce to develop the software. So their software is very commonly used, okay, in Asia, right? For this kind of software, usually we can divide into 3 parts. Okay, first, for this software, we call the pre-processing. Pre-processing means that if you have a CAD model, you need to convert into solid mesh. Okay, and once you convert into solid mesh, you generate solid mesh. The solver can perform the numeric analysis, come with some numerical result, and based on the numeric result, they have a lot of post-process modules to show the result, to evaluate the result, and the user can analyze and evaluate the result. So for this kind of software, actually, they have 3 kind of field their engineer should develop. The first one, they call pre-processing. The second one, solver. The final one, called post-processing. Okay, so actually, my graduate students, some of my student graduate, they work in this company. Right now, I think more than 12 students, okay, work in this company. What they do is that, okay, when they come out, when you have a CAD model, they want to how to develop software to pre-process your model so they can generate the mesh more quickly, more accurate. So most of my students work on this field. We call computational geometry or pre-processing or CAD group. Okay, so in terms of composite material, I think they have another group working on this area. Okay, that's my field. Focus on the CAD or computational geometry. That's my main field. All right.
Okay. Thank you, Prof. Jiing-Yih, and for the clear answer. And please give the big round of applause to Prof. Jiing-Yih. But we still have around 20 minutes to finish these sessions, and we have 2 audience that has raised his hand. For the first, I will give chance to the Mr. Rudy Kurniawan. To Mr. Rudy Kurniawan, if you want to give the question, please, time is yours.
Yeah, thank you, Dr. Nasruddin. Professor, my name is Rudy Kurniawan. I'm a lecturer at the same university with Dr. Wang.
Yes.
Good that we have also vice rector who is responsible to buy equipment here in our meeting, Professor Hamdani. So my question is related to the first question is, what is the motivation of this research? I mean, is the idea come from your research group, or this one is based on request from the industry? Mm-hmm. So the next question is, what kind of equipment that we need to conduct this kind of research? I mean, of course, we need the molding, and then also the software and so on. Maybe would you please elaborate what kind of the hardware or software that we need to conduct this research? Maybe we can propose to Professor Hamdani. Thank you very much.
Okay, for the first one, because those projects come from industry, all right? So the original requirement come from the industry, okay? For the first company, for example, this company called Tech, we already cooperate with them for 8 years. So this is 9 years. Okay, so for this company, we already cooperate with them for 9 years. And for the second company, this is the 4th year. We already cooperate with them for 4 years. So around 4 years ago, okay, we start to contact them, and they discuss what they need. Okay, actually focus on the morpho analysis. Okay, so this is the concept. They need this kind of requirement, and we start to contact with them, and what they need is fit for our field. From that time, we start have this kind of the cooperation. After 2 or 3 years later, they know that okay, we have the capability, okay, to develop some program. Okay, so from this year, okay, we initiate some new area in terms of okay, how to develop a new program and to embed it in their system and to help them. So this is the trend there. And for the third company, okay, maybe this we can answer for the second question. So what kind of equipment we need? Because okay, we have long-term cooperation. All right. So for morpho analysis or okay, all for the injection model, we need 2 kinds of equipment. The first one is the software. All right. So for the software, okay, this company install the software to us freely. So we actually each year we can open their new version of software because we already cooperate with them. They can support our software, so it's free. But very initially, we got a software from them using the educational price. So it was very cheap. All right. So you need to get the software first. Okay. Also, for this kind of project, okay, you need to run real experiment. But actually, in university, it is very difficult to have this kind of machine, and you don't have this kind of operator, skilled operator to run the experiment for you. So this is the reason we cooperate with this company. Whenever we want to run experiment, we go to their company. They help us to run the experiment. Okay, so actually in our university, in our lab, we only have software. And then we only know how to develop program. Of course, we know how to use case system and how to perform the design. And when we want to fabricate, the real part, okay, we ask some other company to fabricate the part for us. Okay, and whenever we want to run the experiment, we just visit this company. All right, and after we come with the result, we organize all results and we report the result to this company. So they can learn from the entire process. For example, initially, they were not familiar with morpho analysis. So when we report the progress in terms of the morpho analysis, so right now they know that morpho analysis is helpful for them. So they also get a module from this company, that kind of issue. So what my conclusion is that for the previous 20 to 30 years in my lab, okay, I don't want to buy any hardware except computer, because whenever you have a lot of hardware, you need to train the student to learn how to operate the hardware. But the problem is that once student graduate, the new student, they need to take time to be familiar with the hardware. And whenever you need to initiate a new project, the original hardware may not be useful for your new project. That's the problem. So in our lab, we only have case system. We only have model-based 3D. We only know how to develop program. I think Dr. Wang know our lab very well, right? Even when he come to our lab, initially maybe he want to place something, okay, really exist but he stayed here maybe 3 or 4 years. And finally, he did not learn anything from real estate. He only know how to operate software, and he can publish a lot of things simply using software. So what I mean that in university, maybe it is a good chance if you know a lot of software and even know how to develop program. It may be a good environment for university people to learn something, to develop something, to accomplish something, right? That's just my opinion. Okay, not be suitable for other people, right? Okay, thank you.
Yeah, thank you very much, Professor.
Okay, is it clear for you? I think for Mr. Rudy, but if we want to know many about the equipment, maybe you can visit Prof. Jiing-Yih Lai, Mr. Rudy. Maybe you have time, you have chance to go there.
Okay.
Okay, then because we have only I have a question from the students that are Aldi Leonardo. He has a question about the why we not only use the natural cooling for the system, and for the simulation, is it involve the energy and heat transfer for simulation? Is it, I think, is it in one simulation also with the manufacturing simulation? Okay, there you got the point of the question, Prof. Jiing-Yih.
Dr. Nasruddin, I'm very I'm sorry,
Okay. Yeah.
because it's too many questions, professors. I list is more than 15 questions. More than 15 questions in chat room.
Yeah.
Too much for me.
15 questions. I think you cannot answer all right now.
But you can name maybe 1 or 2.
Yes,
right?
yes,
Yeah.
right. I suggest to Dr. Nasruddin, we already collect some questions, and then we try. I mean, we can send to you, Professor. You can give some comment also, because the time is limited. Right? I know you very busy. Also, you have another appointment. So maybe for the rest question, I mean, in the chat columns, we can answer letters. Maybe it's like that. But the main point for me, as the last conclusion from you, we need you encourage in terms of the programming. So in terms of the programming, I know I missed that skills. I missed that when I was there. I missed that. So I want to emphasize the student and the college also.
One question to ask you. In your department, okay? No, I mean all your university, because you all professors come from different university, okay? Yes. Do you offer programming in your undergraduate level? Programming?
Yes, we have the subject. We call it introduction to the computational.
Do you learn language programming? Language?
They do. As I know, still not yet learn about the programming. Just use the the application of program. Suppose like we introduce the MATLAB, and then we introduce also some like the CAD systems. We introduce also ANSYS, suppose like that. But for the programmings, I think not yet, professors.
Suppose okay. Because you mentioned AI in the very beginning, okay?
Right.
AI, although I'm not familiar with AI, okay, I have a student who is working on AI. He will graduate sometime this semester, so he is familiar with AI. But I'm still not familiar with AI. But I know that okay, a language called Python. Anyone know Python?
Yes, Python. Python, yes, we know Python.
Do you offer this kind of course for Python?
Not yet, Professor.
All right. Okay, this may be one opportunity. So if you want to learn Python, maybe some of my students or myself, we know a little bit about Python. All right. Based on this opportunity, maybe we can try to do some meeting or something we can introduce Python to some of your students. And because Python is very popular in the world, all right? Because, okay, you know that basically we call it Visual C++. But Visual C++ is a little bit difficult. Even if you learn Visual C++, you may not know how to do something. But if you know the beginning of Python, okay, you might learn a lot from the internet, and it might be helpful because a lot of modules are developed especially for Python. Even so, you want to learn AI, okay, and usually we use Python to combine with the AI. So if it is possible, we can organize this kind of meeting. I can ask my student, okay, to discuss something about Python to give you some in the beginning. One student how know the resource, how they can learn Python by themselves. For example, in our department, okay, our college, we organize one kind of, we call the competition. We call programming competition, all right? Actually, students, they learn by themselves, but we just organize one kind of competition, okay? They can compete or try to programming and to compete. And once they, well, the bottom line, they can learn how to programming by themselves. And the Python is the most popular one. If we are interested in this one, we can discuss, okay? And because some of my students, they know how to work on this one. If you, even in your lab, if some of your students try to understand some, well, we can organize.
Yes, yes, thank you, Professor. That's we expect after finish this lecture speaks, maybe we have some discussion.
Sure.
We are very like I mean it's meaningful if we can learn, and some students from your lab also give training for our students also. I mean this
okay.
one is a good thing.
Yeah, this is a good opportunity and beginning. Okay, and you can let me know what kind of language, okay, you or other professor student they want to learn, and we can organize this kind of the meeting. Not only once, maybe a couple of times, because okay, in my lab right now I have at least 10 students. 8 of them are master students, 2 of them are PhD students, and 100% of them are familiar with coding. All right, and if you want to learn some kind of coding, yeah, we can discuss this kind of issue, right?
Okay, thank you, Professor.
So keep in touch, right?
Yeah, yes, I will keep in touch with you. And then this Dr. Nasruddin, maybe can closing or something.
Okay, thank you because the limit of time and text schedule of Prof. Jiing-Yih. Maybe for this session, we cannot continue for this session because the time is over. And for the next question and for the other question, we will send, maybe if you don't mind, we will send by email to you. Okay. And for the audience, is cannot have time to question because I see there are so many people raise his hand and we cannot give the chance and give the time to question. Maybe you can write the question at the chat box and we will send by email to Prof. And for today, thank you, Prof. You have shared very interesting knowledge, very interesting experience from you. And for us, it's very useful. And hopefully we can follow your research. And maybe for the next, Mr. Dr. Irwansyah can lead us or to collaborate in this area with your university or your lab. For today, I'm as a moderator. You see, one more thank you a lot for your sharing of presentations. Maybe before we close the session, you want to take picture as a documentation. Please, host, take the picture for all of us.
You can take picture?
Yeah, it's okay. It's okay.
How to take picture?
No, you just sit and look at the camera camera, they will take a picture.
Take
Thank you,
picture.
Professor. Until now, it's more than 100 participants who attend this lecture speaks. More than 10 participants who attend.
Yeah, I need to learn how to use Zoom. Okay.
Right.
This is my first time. Right.
Right.
Okay. Thank you so much.
Okay. Please, Dr. Nasruddin.
Okay, Mr. Fajri, as a host, please take the picture, all of us, so we can get a documentation for this session today. Okay, I will take it. May I count? 1, 2, 3. Smile.
Cahayu.
Cahayu.
Thank you so much.
Okay, thank you for all. For the next, I will give time to Mr. Iwansa to close this session conference. Please, Dr. Iwansa.
Thanks, Dr. Nasruddin, already organized and lead from 2 of Universitas of Langsa, Universitas of Universitas Samudra, Langsa, Universitas Samudra, Universitas Syah Kuala, and thanks for all of the participants, college, lectures, and students, and all of who already spent their time to attend the lecture speak from Professor Lai. Thank you so much, Professor Lai.
Thank you.
Already give us new knowledge, new information, and then we hope for the next, as you already mentioned, we can conduct some like the programming training also. We need that one to emphasize and encourage our student skills also. And for me is thank you for all. We will close this lecture speaks. Maybe we can meet in another lecture speech. We hope we still getting help and then still consider about the COVID-19 protocols. Okay, thank you, Professor.
Thank you, Salah. Okay,
thank you,
everyone.
See you. I will keep in touch with you.
Okay, thank you, Salah. Thank you, Professor. Okay.
Okay, thank you.
Thank you.
All right, thank you.
Yeah, thank you, Professor.
Okay.
Okay. We can close this, please. Makasih Pak Nas, makasih Pak Rudi, Pak Topan, dan beberapa, makasih semuanya.
Terima kasih semuanya.